Hi, Chelsy. How are you doing?
I'm good. How are you, sir?
Very good, very good. So today, what do you want to do?
Today I have a test coming up on reciprocal functions, so I want to cover that today.
Sure, why not? So do you have any questions or doubts which you would like to clear, and or how do you want me to, help you out?
I have some questions that I did from my assigned homework
Mhm.
that I had some trouble with, so I wanted to ask you that.
Sure, let's take them first, and then I can actually provide you with some more questions which can help you for your assessment. Okay? Why
Okay.
don't you share your questions first? Let's begin from there. So you're following Nelson, right? MHF4U?
Yes. So the first question is question number 12.
Let me, yeah, okay. Question number
So,
12. Can you
uh,
please read the question?
yeah. Polluted water flows into a pond. The concentration of pollutant C in the pond at time t minutes is modeled by the equation C of t equals 9 minus 90,000 times 1 over 10,000 plus 3t, where C is measured in kilograms per cubic meter. Part A is when will the concentration of pollutant in the pond reach 6 kilograms per meter cubed? And B is what will happen to the concentration of pollutant over time. So I was able to get the answer to part A, but I did not know how to do part B.
Okay. So first, share your answer with part A. So you want to find concentration, when will it reach 6 kg per meter cube? How did you find that?
So the first thing I did was I added the equals 6 to the equation that was given. And then I had the equation negative 6 plus 9 equals negative 90,000 times 1 over 10,000 plus 3t. And then I solved that to get t equals 6.6667.
6.667.
Yeah.
So that was your time in minutes.
Mhm.
So what is happening? The pollution is decreasing, correct?
Mhm.
So ultimately, see, if that is the process, 90,000 divided by 10,000, if T is very large, if T is very large, let us say, in that case, what will happen to this?
If t is very large, then the number will get smaller because it's 1 over a large number, right?
1 over very large number, correct. So when you plugged in, so this number will be very small. So how do you think the graph will be for this particular function?
Will it decrease?
Yes, because it is 90 minus something, right? So when T is 0, at that time, you're doing 9 minus 90,000 over 10,000, which is 0, right? So at T equals to 0, if you see, at T equals to 0, if you plug in T equals to 0, what do you get C of 0 as? C of 0 will be 9 minus 90,000. Let's try to understand how do we get the solution. Is it okay? So we have 10,000 here plus 0, right? Because I've substituted T as 0, correct?
Yeah.
So this basically is equal to 9 minus 9, which is 0. You get the idea. So you're starting with pollution of 0. Do you see that? At T equals to 0, there is no pollution. Now, gradually, it is getting polluted. Correct? So,
Right.
if T is very large, in that case, you're not subtracting anything, right? So, you saw that when T was equal to, let us say 6.7, the pollution level, that is C, at 6.7 became 6 kg, right? Per meter cube. Is it okay? So with time, it is increasing. Pollution is increasing with time, correct?
Right.
Now, what happens when t approaches infinitely large values? Let me put this: t is approaching infinitely large value, right? In that case, c will approach what? C is going to approach a value which will be 9 minus 90,000 times 1 over very large value. Do you see that?
Mhm.
So it is going to approach 9 because anything divided by a very large value will be 0, correct?
Right.
So you're approaching a value of 9. So if you look at the scale, let's sketch a graph for this. So we have the pollution C with respect to time here, and this is time for us, correct? So initially, it is no pollution according to this particular equation, right? However, it is increasing and it is going to approach a value which is 9. So 9 is going to be our horizontal asymptote. You get the idea,
Mhm.
correct? You already found one value on this curve, which is kind of like this, 6.7. You got a value of 6. That is 0 for you. Do you understand how you can explain it?
Yeah.
So at t goes to 0, the pollution level is almost 0. Then it's get polluted, and the pollution is very fast, So it is increasing, but at the most, it is going to go to 9 kg per meter cube, as
Mhm.
per this given model. Is it okay?
Yeah.
So we'll say this will be our horizontal asymptote. So it'll approach 9 kg per meter, as shown in this particular graph. And that is how you could explain. Clear?
Thank you, sir.
Okay, so let's take up the next question.
The next question was 13, also part B.
Also part B, okay.
Yeah.
So first question, part B, was mainly a communication part, which is very important, and also to understand the graph of the particular function. So in a way, you realize we have sketched the graph for the function, right?
Mhm.
Okay, let's look into question number 13. Can you please read the question?
3 employees work at a shipping warehouse. Tom can fill an order in S minutes.
Let us write down the equation first. So from here, Paco can fill in S minus 2. Carl can do the work in S plus 1 minute. So we can write the speed is Tom in S minutes, correct. So we have, let's clear this. Okay, so let's write down the speed of each person. So for Tom, it is S minutes.
Mhm.
For Paco, it is S minus 2. And for Carl, it is S plus 1. So now we are given a condition: when Tom and Paco work together, they take 1 minute, 20 seconds. So working together for Tom and Paco, they take 1 minute and 20 seconds, which is 1 minute plus 20 over 60 minutes, right? Which
60
is
seconds.
1 plus 1 over 3 or 4 over 3. Perfect. Now we can write this in the form of an equation as 1 over S plus 1 over S minus 2 equals to 1 over 4 over 3, right? Or 1 over S plus 1 over S minus 2 equals to 3 over 4. We can actually cross multiply and solve it, right? Did you solve and get the answer?
Yes.
What was the value of S?
4.
S is 4. So I'll just check the answer, okay? So solve, and what you get is 4, okay? Let me check it. So 1 over 4 plus 1 over 4 minus 2. Let's check how much this is, right? 1 over 4 plus 1 over 2, that gives you 4 remainder, 1 plus denominator, 1 plus 2, which is 3 over 4, correct? So which is correct. So your answer 4 is correct. So we know the speeds for each person. This is 4. This is 4 minus 2 as 2. And this is 4 plus 1, which is 5. Is that clear to you now?
Yeah.
Now let's do part B. Part B is how long would all three of them working together take to fill? Of course, they will take much lesser time. And that should be how much? 1 over 4 plus 1 over 2 plus 1 over 5. That is all.
Yes.
So let's take the common denominator, which is how much? 20, right? And add them up. So this is 5 plus 10 plus 4. So that gives us 19 over 20. And that is the time in minutes. So this answer is equal to basically 1 over t. Is it okay?
Okay.
1 over t.
Yeah.
Total time taken, correct? So time will be 20 over 19 minutes. So you can say 1 minute and few seconds. Is that okay? To convert that to minutes and seconds.
Yeah. So we had to find like the reciprocal, right? That's why you flipped it.
Yes, because that was 1 over t. Very important to understand. Let me just highlight this portion. So it is 1 over t. So this was 1 over t equals to this. So the time is 1 minute and 1 over 19 times 60 seconds. Is that okay?
Yes.
So
Sorry,
19
why?
is approximately 20. You can say 3, right? 3 seconds. 1 minute, 3 seconds. You can say approximately 1 minute and 3 seconds.
Okay.
Yeah, very important. As you said, it was 1 over t. So that we have to flip it to get the right answer. So is this absolutely clear to you?
Yes. One question, sir.
Yeah,
sorry.
ask. You want that?
Why did you multiply by 60 seconds again?
Oh, to convert the minutes to seconds. So we got the time.
Oh.
Let me rewrite this, correct? So time was 20 over 19. So 20 over 19 gives me 1 over 19 minutes, right?
Right.
So I converted this 1 over 19 minutes into seconds by multiplying it by 60.
Oh, okay. Yeah,
so it is
I
1
see.
minute plus 1 over 19 times 60 seconds. Is that okay?
Yeah.
That's perfect. Any other question for you? So that means you have worked a lot. You solved all these questions without any problems, right? Only these are your doubts?
Yeah.
That's very good. That's very good. Question number 9. Can you please read it?
The equation f of t equals 5t over t squared plus 3t plus 2 models the bacteria count in thousands. For a sample of tap water that is left to sit over time, t in days. The equation g of t equals 5t over t squared plus 9 models the bacteria count in thousands for a sample of pond water that is also left to sit over several days. In both models, t is greater than 0. Will the bacteria count for the tap water sample ever exceed the bacteria count for the pond water? Justify your answer.
Correct. So it's an inequality which you have to solve, correct? So we are given two functions. So we're saying first function f of t models bacteria count in thousands. Remember that. Both are in thousands, that's good. For a sample of water, tap water. And g of t is bacteria count in pond water. The question is, will bacteria count for the tap water sample ever exceed? So we basically want to solve this equation. What is this value? Is that clear to you?
Yeah.
Because the tap water is f of t. So that's the inequality which you need to solve. So let's see how do we solve this inequality. So we have 5 over 5t over t square plus 3t plus 2. We want to see whether it is greater than wait for a second. We want to see if it is greater than 15t over t square plus 9. So I think you can factor the left-hand side. So it gives you 5t over, so 2 times 1. So it is t plus 2 times t plus 1. Bring this term to the left-hand side. It's an inequality. So we can bring it to the left-hand side. So we get 15t over t square plus 9. And we want that to be greater than 0. Is that clear to you?
Yes. Yeah.
Remember one thing, that in this particular case, t is greater than equal to 0, right? So t is positive. T is not negative. So if you get a solution which is not positive, then it is not the real solution. Is that clear to you?
Yeah.
Okay. So that is one thing. Now, to begin with, let us take some estimate just to answer this communication question. This is an application and communication question. If I put t equals to 0, in that case, both are same. Do you see that? T equals to 0 gives me both the things 0. Do you see that? So initially, we are saying that this equation models the bacteria count. They have the same bacteria count at t equals to 0, which is 0. Correct? But they both model t greater than 0. So this equation is only valid for t greater than 0.
Right.
Okay? Yeah. So now, as t approaches a very large number, let's try to analyze what happens when t approaches a very large number. So if t approaches a very large number, both of them will approach what? See, denominator is of higher degree than numerator. So that means that the horizontal asymptote is 0, correct? So for a very large number, they are actually approaching 0. Okay. Now, let's try to solve this. So we'll take a common denominator, which is product of all these. I'll write this as t square plus 9 times t plus 2 times t plus 1. Multiply them. So 5t times t square plus 9 minus 15t times both these factors, correct?
Yeah.
Which is, I'll write the standard form. That'll be better because we have to expand, right? T square plus 3t plus 2. And we want to show that this is greater than 0, right? There's less space. Okay. Since t is greater than 0, so we know that t is greater than 0, right? So that means t is positive, correct?
Yes.
So we can divide both these sides by 5t. Is it okay?
Why are we doing that?
And we can also multiply by, see, t is, all these terms are, if t is greater than 0, let's try to understand. In that case, t square plus 9 is greater than 0, correct?
Yes.
T plus 2 is greater than 0. And t plus 1 is also greater than 0. Is that clear to you? So we can multiply, they are all positive numbers. So we can multiply with all these numbers and cancels, right? Do you see that?
Yeah.
So what we get here is that we get 5t times t square plus 9 minus 15t times, I'm doing it in small steps, t square plus 3t plus 2, right? We want to show that this is greater than 0. Is it okay? Now, since t is greater than 0, see, The only thing in inequalities is that if you divide by a negative number, then inequality sign changes, correct?
Right. Yeah.
Because t is positive, we can divide by it, sign will not change. Correct?
Mhm.
So we cannot divide by 5t. You can divide all these terms by 5t, right?
Okay.
So in that case, you are left with t squared plus 9 here minus, instead of 15, it becomes 5t, right?
Mhm.
5t times t squared plus 3t plus 2 greater than 0. This is the inequality which you need to solve.
Yeah. So we're only dividing like the leading coefficient by
Yeah,
5.
I mean the whole term. So in the whole term, that 5t is common factor, so you can cancel.
Okay. So we don't need to do it for the things in brackets.
Because they cannot cancel. So I'm just simplifying in steps.
Okay.
Right? Now we have a quadratic equation to solve. Right? In fact, 5t. So this t also got cancelled, right? So 5t, this t is not there.
Just 5.
Oh, we do, so 3t, sorry, 3 is there. Sorry. We divide by 5t, 15 divided by 5 is 3. So times 3, sorry for that. So 3 times t squared plus 3t plus 2, right? So that's a quadratic equation to solve. So let me expand this. And then, so we have next statement, which is t squared plus 9, open this bracket, minus 3t squared minus 9t minus 6 should be greater than 0. Clear? So t square minus 3t is minus 2t square minus 9t, and 9 minus 6 is 3, right? Should be greater than 0. Is that okay?
Yeah.
So that is the equation which we need to solve. If I multiply by negative, so let me take it here. So if I multiply by negative, I have 2t square. I want to keep the leading coefficient positive. Plus 9t minus 3 less than 0. Is this clear to you? So we multiplied by negative, or you can take the term to the other side to make them all positive leading coefficient. Is it okay?
Yeah.
Now, can you factor this? 2 times 3 is 6, and we need a number. Now we can use quadratic formula, right? We want this to be less than 0. Let us see if it is equal to 0 or what, correct? 2t square can be, we'll use quadratic formula to factor to find whether it is equal to 0 or not. Is it okay?
Okay.
So find factors. So t equals to minus b, which is 9, plus or minus square root of 9 square, which is 81, minus 4ac, minus becomes positive. 4 times 2, 8, 8 times 3 is 24. Square root divided by 2 times a, which is 4. So I've used the quadratic formula, which is x equals to minus b plus minus square root b square minus 4ac over 2a. Is that clear to you?
Yeah.
Can you use the calculator and find the value? T equals to minus 9 plus minus within square root 81 plus 24. What do you get?
1 second, sir. I
105.
forgot my calculator.
Oh, okay, just get it. Divide by 4. Even I don't have it here, right?
Yeah.
1
second.
So we are looking for square root of 105. Square root of 100 is 10, correct? Square root of 100 is 10. Minus 9 plus 10 is going to give me a positive number. Do you see that?
Could you repeat that, sir?
Minus 9 plus square root of 10 will give me a positive number, right?
Okay, yeah.
Because we know that t is greater than 0, right? Remember, t is greater than 0. Is it okay? So one of the values which we are going to get from here is positive value. So which is what? Calculate. What do you get? Minus 9 plus square root of 105 divided by 4.
So one of the answers is negative 6.4.
So we'll neglect that.
Mhm.
Negative 6.4, but I'll write down. So negative 6.4, okay, that is one answer. The other one is what?
Wait, I think I did a calculation.
So do square root of 105 minus 9 divided by 4.
So one answer is 0.3.
Yes.
Yeah.
We do have an answer which is very close to 0, which is 0.3, right?
Mhm.
So the value of t, so we have two zeros here, right? Which one of them is not counted. However, this is a quadratic equation. If you sketch this quadratic equation, it will be a parabola of this kind. Do you see that?
Yeah.
And you get two values. One is 0.3, right? Correct?
Mhm.
Our graph is only valid for t, which is positive. Is it okay?
Yeah.
So say 0, right? But you can see that within this interval, the first 0.3, the units are in which unit? What is time in?
Mhm.
T in days.
Days, yeah.
Days. So 0.3 days. For the first 0.3 days, f of t is greater than g of t. Because we got a valid answer, 0.3.
Mhm.
You get the idea? So this inequality is true only for a very short duration of time, and that is 0.3 days.
Okay.
So you can say in hours, so 0.3 times 24. You see that? So many hours, it is the pollution for number of bacteria count in the tap water is more than the bacteria count in the pond.
Okay. Yeah.
So that is what we have. So it in first 0.3 days, you can convert to hours, right? 0.3 into 24 hours, correct? So which is 7.2, let's say 7 hours. The pollution, I say bacteria count in tap water is more than that in the pond water. You get the idea?
Yeah.
That's a very small duration, but the statement you can justify now that yes, it exceeds, but for a very short period of time. So approximately 7 hours. Is that okay?
Mhm.
7.2 hours. So that is how you could actually answer this particular question. A lot of calculation to be done.
Yeah.
Right. Did you understand this?
Yes.
Good. Thank you.
Mhm.
That is how we are going to solve this particular inequality. Is this clear to you?
Yes.
Any other questions?
No.
Perfect. So we'll end the class here. Can you please summarize your learnings?
So today we went over how to solve word problems in reciprocal functions. So yeah, we did that. And then we also went over how to use the chart method to find inequalities in reciprocal.
Perfect.
Yeah.
So these are three different types of inequalities. You are actually doing rational functions. This is extended. We have absolute value of x over x minus 4 to be greater than 1, right? I'll share this a blank screen. So the question was, can you tell me what was the question? Absolute value of?
X over x minus 4 is greater than 1. Greater than equal to 1.
Greater than equal to 1, right? So this is an absolute function. We will first analyze when is this function positive and when is this function negative. Is it okay?
Yes.
So you know it has a 0 at x equals to 0, right? And it is undefined. So we say vertical asymptote at x equals to 4, correct? We are just talking about the function which is x over x minus 4. Is it okay?
Yes.
Perfect. So let's analyze in an interval. So we have x equals to 0 and x equals to 4. Now, let's take test points in the intervals defined. So there are 3 intervals. So in the first one, we'll take an -1. Here in between, we can take a value 2. Here we take 5. And we are taking the 2 factors, x and x minus 4. So for -1, it is negative. For these 2, it is positive. But when we do x minus 4, in that case, this negative and this is positive. Clear?
Yes.
So we get positive in this interval, negative in this interval, and positive in that interval. Perfect.
Mhm.
So what you realize is the given function is negative between 0 to 4. Correct? So if I kind of sketch this graph, we have a vertical asymptote at 4, a 0 at 0, right? So this function is basically between 4 and 0, it is negative. And thereafter, it is positive in both the sides. So if you sketch, it is in this interval, between 4 and 0, it is negative. So I'm just writing negative here. I'm not drawing, but it is positive in these 2 intervals. You
Mhm.
get the idea?
Yeah.
So that means we need to solve this inequality for the values. This absolute function can be now defined. When it is negative, it will be in this region, negative of this, right? So in the interval from 0 to when x is greater than or equal to 0, but less than or equal to 4, it is negative, right? So this absolute function will be defined as minus of x over x minus 4. Because it will become positive, right?
Why is it minus? X, why is it minus x?
Because it's an absolute value. So let's try to sketch this function. So x over x minus 4 means we have a horizontal asymptote at 1, correct?
Yeah.
Okay. Now, so we know that it is positive in this side, so it is kind of like this. Is that okay now? This is at 1. Is it okay?
Yeah.
We have seen that it is negative in this portion, so the graph has to be like this. Is that okay?
Yes.
Clear? Perfect.
Mhm.
Now you realize this is the graph of x over x minus 4, correct? Now, if I do absolute value of this, then what happens? If I do absolute value of this, the negative portion becomes positive. So this goes like this. Do you see that?
Right. Yeah.
So therefore, now, when you look at this particular inequality, clearly it is greater than or equal to 1 in 2 regions, right? So in this region, right? So we have to figure out when is it 1. Do you see that?
Yes.
And of course, x is not equal to 4, that we know. So one of the solution definitely is that x is greater than 4. It is always greater than 1. That portion is clear. Is that okay?
Yes.
We have to now work on the interval between 0 to 4 when this value is negative. Between 0 to 4, which I am trying to do. Is that okay?
Mhm.
This should be greater than or equal to 1. Is that clear to you?
Yes.
So that is what we need to solve. Can you solve this now? We know x is positive. Yeah. So we need to now solve this inequality, correct? So we'll bring 1 to this side and then we'll solve. So I'm now using this space. So we have minus x over, rather we'll bring that to the other side, right? So I'll say 0 is greater than or equal to x over x minus 4 plus 1. Is this clear? We'll solve this. 0 is greater than equal to x minus 4 in the denominator, x plus x minus 4, correct? So
Yes.
we have 0. So now I'll remove this page, clear this away. Is this all clear to you?
Yeah.
So note this inequality. We are going to solve this now, which is 2x minus 4 over x minus 4, right? So we are saying 0 is greater than equal to 2x minus 4 over x minus 4. This is what we have to solve. Is it okay? So I'm clearing the screen, redoing. So you want to prove that 0 is greater than equal to 2x minus 4 over x minus 4. Perfect? And we are working with, in which domain? X value is between 4 and 0. Is it clear?
Yeah.
0 included. 0 included, correct? Okay. So let's try to. We already have got one solution, that x is greater than 4 is a solution, correct?
Yeah.
Now, the other part of the solution we are trying to figure out. Let me also sketch the small portion graph for our reference. That is our graph. This is going through 0, right? So we have a graph like this. Is that okay? That is our graph. And we are looking for this value now. So from that value, which is x, we are looking for. So let's solve this. Now this has, you can see 0 at 2, right? And not defined at 4. So this is your 0. And this is your vertical asymptote, correct? So we can take test point from 0 to this place as 1, 3, and 5. And we have two factors, 2x minus 4. Other one is x minus 4. So when you plug in 1, you get negative. When you plug in 3 or 5, you get positive. For x minus 4, we get negative, negative, and positive. So when is it negative? We want 0 to be greater. That means we want this to be negative, right? So it is negative in the interval between 2 to 4. Is it okay? So this inequality is true between 2 to 4. And therefore, we get our solution. That means this point is 2, right? So our answer is the x value is from including 2, but not including 4. And the other one is from 4 to infinitely large value. Is that clear to you? That is how we are going to solve this particular inequality. Is this clear to you?
Yes.
Any other questions?
No.
Perfect. So we'll end the class here. Can you please summarize your learnings?
So today we went over how to solve word problems in reciprocal functions. So yeah, we did that. And then we also went over how to use the chart method to find inequalities in reciprocal functions.
And the absolute function inequality was very interesting chart. You know how to sketch a rational function. The negative part becomes positive. Do you see that? And that's why we analyze that portion between 2 and 4, 0 and 4, to find the point 2, which was the point where it equal to 1, correct? And so we got our solution. That's very critical to understand. So I hope that helps. All the best for your exam or test. See you soon. Thank you.
Thank you.
Thank you.